Following after saving the model, we have done this SQLite database weather DB. We have created it. Then we have created the model and saved the model. Next, our duty is to evaluate it, right? Before forecasting, we need an evaluation to make sure our model is right? Okay, for this, okay, we have our model saved. Okay, so now I need an evaluate model. Okay, let's go to our helpers file. Before that, this evaluate model, for this I need to send my X test and Y test, right? So here in the helper model, this evaluate model is going to be a common model that can be reused for every other model. So any model can use this evaluate model. So this is going to be plugging in some metrics, right? So def evaluate model. So it will receive X test, Y test, and also I need to send the model name. So for start, I'll keep it as none. Save plots equal to false. Okay, it's a default value. We'll setting it as false. Usually people will call it as a defensive programming. It's a practice actually. So even if any unexpected or incorrect happenings are during the function, so this will ensure that everything runs smoothly. So this is evaluate model. Okay, we have set it default. So first I need the model, then I will evaluate it. Evaluate means model dot predict. Okay, so then I'll get the metrics. Okay, here now talking about metrics, so we have the model and we know we have X test and Y test to predict. So we have the metrics, right? See, evaluating regression algorithms, measuring the deviation of continuous predictions y cap from actual values y across n samples. That is, how much deviation is there between the actual and the predicted value. So we have four different kinds of main regression algorithm metrics, evaluation metrics. One is the mean absolute error, mean squared error, then comes the root mean squared error, then the r squared, which is the coefficient of determination. So first, mean absolute error is the average difference between predicted and actual value. So this will sum up the absolute value of the differences between each true output and the predicted output. So and then averages it. So because of this absolute average, this treats all the errors equally. So it is easy to interpret because they fall as the same unit as y. This focuses on the magnitude rather than its direction. It can neglect the bias in our model based on the positive side or the negative side. If it introduces bias, this will neglect it. So as we take the modulus, the sign of a value carrying positive or negative does not matter. So because we are taking the absolute modulo, this is the modulo. Second will be our mean squared error. Here instead of absolute value we are taking the squared. This will be heavier for larger errors. It will penalize largely for large errors. So large errors result in high MSE. Okay, MSE is robust to outliers, MSE is sensitive to outliers as per definition. Then comes the root mean squared error. This is simply taking the square root of the mean squared error. So here if the predicted responses are very close to true responses, RMSE will be small. If they differ, then RMSE will be larger. Okay, this brings back to the same unit because we are squaring the error, right? So here this will brings back to the same unit. Fourth will be our r squared, which is the coefficient of determination. This shows the proportion of variance in the dependent variable explained by the model. This is one good score. Okay, so if r square is equal to 1, we can assume that the predictions are perfect. R square equal to 0, then no predictive power the model has, and if it is closer to 1, it is better. So it is very much appreciable to use r squared error as one of the most important metrics. So we can see RMSE and MSE measure the error, but R square tells how well the model explains data. So this is a Python implementation notation. So from sklearn.metrics we can get all the other metrics we needed. Okay, we don't have a thing called RMSE. We'll just take the NP dot square root for the MSE, and that will be very much easier. So for our model, linear regression model, we'll be using this root mean squared error and this R square, okay, coefficient of determination. So this will be, metrics will become, one is RMSE and the other one is R2 score. Okay, so first we will do it. For the model, I need to load model. Right? So we have load data function, we don't have load model function. So we have save model function and we are writing load model function. So this will get the name. With the name it will load the model. So that is why we saved the model with name, right? Along with the model object we gave the name also. So we can call it using the name. This will return joblib dot load of, we need to give the path, os dot path dot join of, it is under models directory. So if I'll attach the name dot pkl. Okay, this will be the file name along with the path. So this will close it. So we will get the model from this load model. So I can call the model here. Now next the model dot predict, right? So for prediction we need X test. Okay, so X test. If we have the column called date, we need to remove it. In case of any error occurs during that dropping of date column, we will just ignore it. Okay, so this will give us the evaluation set. I'll close this. Next, for prediction, we will send the XEval data without date only. Okay, this will predict the data. Okay, now, so what if our method fails in any of these cases? So we should not leave it hanging. So we try to fit it in everything. Okay, if there is any error while loading the model, we'll get the exception as E and print the status as accept exception as E and print error failed to load model. Okay, here we'll have the name here. Okay, so and the error. Okay, we can also, instead of using this print, we can also use the logger. So since this is an easier way, I'm going with this. We can also, in production level, we have to use the logger, right? So that will be like import logging, and with that logging dot get logger, we can configure the structured logging there. So with that we can add, instead of giving this printf error, and we can directly put that logger dot error of this error statement. That's all. Okay, so this is one kind of logging. This is the best way in the production grade level, but for simpler I have kept it under try and except. Then comes the evaluation part, right? So if any problem with this code, we will give it as accept exception as E. Now the error will be on prediction failed for model. I'll pass the name with the exception. Okay, Okay, we'll close this. Okay, then comes the metrics. RMSE will be, we have to actually import all the functions that will be from sklearn.metrics import mean squared error R2 score. So these are the two metrics. So now I can use it here. So for that RMSE will be uh, RMSE will be the based on this image, which is a good representation, np dot square root of MSE, right? So we have mean squared error and we can take the square root of it. So I'll first get the mean squared error. I'll pass the y test and our prediction. Okay, so this will be our prediction, and taking the square root np dot sqrt, this will give me my RMSE, root mean squared error. Then this will be R2 score of y test comma pred. Okay, okay. So even if we get any kind of error, I'll try to catch it. Set exception as E. Now print error failed to calculate metrics for mean and exception. Close the brackets. Okay. Also, we can also try to throw that what if it is success. Okay, so this is a common thing I am using. Metrics calculated for the model with RMSE score here and R2 as here. Okay, so this will be our metrics. So we'll see, this will return, what this will return is two things. One is the RMSE, another one is the R2. Since we are evaluating it for everything, for all the algorithms, why not return them with a model name also, because we have this name along with us. So what if in future, if we use all the algorithms in one single notebook and we want to compare everything all at once, so at that time we need name. So for a safety precaution, I will be returning model with name, then RMSE with RMSE, then R2 with R2. Okay, this will be my dictionary kind of written. Okay, so let's try this. This is model loading, evaluation, then the metrics calculation. Okay, let's go to our linear. Now I need to restart my kernel. So we have already saved our model, right? So one good thing we can do now is what? We can directly call the model instead of saving it again. I'll run the inputs first. We'll check everything is in place. Okay, there is no need to run these because we already have saved it. Now our evaluation model needs. So I need to call this evaluate model with the name. That will be my total evaluation result, right? So the evaluation result, I'll get the dictionary in metrics and I'll print it. First will be RMSE, where metrics of RMSE will be shown. Then in new line I'll type the R2 score, that will be matrix of matrix of R2. Okay. Okay, now this is enough. Okay, let's run. Evaluate model is not defined. Let's see the helper file. Evaluate model. Xtest, ytest, name none. Evaluate model, xtest, ytest, name none. Okay, we have given everything right. Utils dot. It should be utils dot. Alright. Okay. Another error, RMSE where it is not associated with a value, which means it has raised an error here. Okay, so let's go and inspect. Okay. Okay, let's try this one. We'll add return none here. Let's kernel, restart kernel. So let's inspect the helper file whether we have did everything right. Xtest, ytest, name, save plots done. So try and load the model. So load the model, I need to pass the name. Okay, now name. Oh my god. Okay, now the exception. I will return none. What if it fails here? I need to stop the loop. Okay, we will return none here. Okay, then matrix also return none here. Success. Okay, if everything goes good, I'll return here. This will be my evaluate model. Now I'll restart the kernel. Okay, we will get the data. I'll directly go to evaluate model. Yes, we have got it. Now this will become model evaluation. See, we have got around 0.433 RMSE and R2 is 0.873. Let's evaluate the model. Okay, for this the RMSE score is what? It is 0.43, right? 0.433. Let's keep it this way. So this RMSE will tell the average prediction in the same units as our target variable. So this measures like how much our linear regression model predictions will deviate from the actually observed values. Okay, that is on an average. So if we have this is kind of low RMSE, that is 0.33. If our prediction is around 32.5, let's say 32.5 degrees Celsius, then our model will be predicting it as 32.1, around 32.9. So plus or minus is 0.43. Okay, so this is how RMSE helps us in measuring the prediction power. Okay, then comes our R2 score. So here R2 score is 0.87. Okay, that is our linear regression model. This is around 87%. Okay, so our model represented and explained 87% of variance using the our feature engineer features like the lag features and other predictors all. Okay, so out of this, apart from this 0.87, we have 16 point, that is okay here around 16 percentage. The balance variation is due to the factors not captured by the model. Okay, if there is any sudden weather events or noise, if any, so because of that this remaining 16% of variation might happen. Okay, so with this let's conclude, we may conclude that with this 0.4 plus or minus, that is okay, plus or minus 0.4 degrees Celsius, and around 87 percentage explained variance. So this model is simple yet strong, what to say, reliable performer. Okay, so this is how our model evaluation is being done. Then comes our forecast. So this is the hero of our project. Okay, so let's see our model idea. Okay, we have done this part, and we did this also, and we have had the evaluation part also. Now forecasting. So our forecasting idea is getting the recent history, making the feature engineered features, then get it in this ND loop. Okay, so we are getting X test for evaluation and a new date for our forecasting. So our forecasting idea is our data will have data till 15 June. So our prediction for the next day will be 16 June. Once the prediction is done, we are sending it back to the history, adding the 16th data to the history. So now our history has both 15 and 16. So keeping that, we will predict the value 17. Okay, so next with that 17 will be sent back to the history. So with 15, 16, 17, it will predict 18. So 16, 17, 18 are our 3 days, okay, with the predicted value. So this forecasting repeatedly is called as a recursive forecasting, and let's see how we are going to do that.